Okay, I'm just giving you the example. What if, okay, if I'm giving you example, suppose here is a resistance connected. Suppose the resistance are connected like this. Three resistances are connected like this. Okay, Hamza. So apart from teaching, it is also my duty that identify your problem and give you the solution. So these resistances are connected in some combination, and suppose this resistance is 2 ohm, this is 3 ohm, this is 5 ohm. This is the case, and battery of 10 volt is connected here. This is a symbol of battery, and this is a wire, and on this wire three resistances are connected. So Hamza, suppose I have given this question to you. This is one of the simplest question, and if you don't know, if you don't know which combination is this, then you cannot solve the question at all. If you don't know which type of combination is this, you will not able to solve the questions correctly. And if you know this the type of combination, actually this is a series combination we have discussed. I am just giving you an example. Yes, I am telling you how you will solve your problem. So you should know in series combination the current is same because the wire is same. This thing you should know. If you know something about the topic, then only you can solve the problem. You should know the current is same. And someone is saying that find the current through each resistor. If someone is saying find current through each resistor, find current in each resistor, if someone is saying, just listen carefully. So for that you should know that the current will be same in all the resistances. This is the simplest question. I am just giving the example. You will get the problem in higher level question also. But you should know at least these basic things. So what you should do here, you will apply first, you will just calculate the equivalent resistance here, because you know that when you will calculate current is equal to I is equal to V divided by R, this formula you should know for calculating the numerical part. For the numerical part, this formula you should know. And if you want to calculate the current, what you will do, you will just put this value V. You should know this is voltage. You will put the value V, and what you will put, you will put the value of R, and here R is given as 2 ohm, 3 ohm and 5 ohm. But you will not take 2 ohm, 3 ohm and 5 ohm. You will take the equivalent resistance, and for that you should know what is the formula in series combination for calculating the equivalent resistance. So equivalent resistance, we calculate the addition of all the resistance. So add all the resistance, 2 plus 3 plus 5. You will get the answer 2 plus 3 plus 5. So you will get 3 to 5, 5, 10 ohm. So R equivalent you will put here. For calculating this current, you should know this formula. I only formula is not uh, by using only formula means by knowing only formula you are not able to solve the question. You have to learn the formula, but along with this you should know the concept also. See, formula of current we all know. Current is equal to potential difference divided by resistance. But which resistance we will take, this thing is important. Here I have taken the equivalent resistance. So you will get the answer 10 by 10, that is 1 ampere current. And one thing more, if someone is asking you that find the current through each resistor, and you know that this is a series combination, so you will say here also the 1 ampere current, here also the 1 ampere current, across this resistance also the 1 ampere current. So you have to club all these things, then only you can solve the problem. You are getting the problem in solving the question. If you are getting the problem in solving in concepts, then there is a reason of that now. So reason is that first first and foremost thing of this, that you should, that I am teaching to you, you should revise your notes by writing. You should revise your notes by writing. Write the notes again on your copy, and when you will revise you will get doubts, and you will get doubts, then We can discuss, we can give 10 or 5 minutes for your doubts. Okay, Hamza. So this thing will be work out. Otherwise, I am teaching, you are just joining the class and leaving the class on the time. You are a good student, I know that, but uh, our main motive is to, what is the main motive? The main motive is that you should get the good marks in your examination, and you should know the physics of 12th class at least. So I will suggest you to solve the assignment as much as possible. I am not forcing you to solve the assignment, because I will solve the assignment if you will not solve. I will daily solve the assignment, whether you will solve the assignment or not solve the assignment. So this is the thing. There are some important tips that I want to give you, and it depends upon you whether you are following this or not. I can just tell you, I cannot force you to follow. Means you have to divide your time. Means we have the, so only 2 classes, means 3 hours we have in 1 week. So in one class, if I will give 2 questions, in second class I will give 5 questions. So can you not solve 5 questions in a week? Of course you can solve, if you will, if you at least try now. I am not saying just I want that question at any cost. I am just saying just try that question honestly. If you will try the questions honestly, then this will be better for you. And revision is very important. I am saying this again and again. Then only you can connect the things. So just I am starting our topic. So Hamza, let's see. Do you know what was the last we have discussed? Do you have notes? Hamza, do you know what was the last topic in the last class we have discussed? Okay, actually we have solved the short circuit type of questions in the resistance. So that I am giving you the advices, and it depends upon you whether you are following or not. Okay, that is fine. So we will now have type 4. Type 4 questions means, type 4 question means there is a combination of resistances, and that have the special name known as the Wheatstone Bridge. Known as the Wheatstone Bridge. So Wheatstone, what is happening here? Just wait 1 second. Actually, I think there is some problem here. So no problem. You just use the next. We can add the page here. No, it's fine. No, it's fine. Fine. So Hamza, let's discuss the our topic. So we have the topic Wheatstone Bridge. Very, very famous and very, very important also. I am giving it 2 star because this will appear in your examination. There are the chances that the question from here will appear in your final examination. So you have to just focus here and everything will be easy for you. I will explain each and everything. The name is Wheatstone Bridge. Wheatstone Bridge. So this is a special type of combination of resistances. So Hamza, I am just making that. And Hamza, one thing more. Uh, if you have any problem with my teaching style, that I am saying that uh, if you are thinking that I am teaching you too slowly, that the syllabus will not be completed on time, and if you are thinking that I am teaching very fast way, that you are not getting that thing, that you can write in the chat box or you can tell to me directly. Okay, Hamza, are you getting my points? So you are always free to say if you are feeling that the things are not well. So this is the type of the circuit, and suppose here is a resistance connected here. And one thing more, try to interact in the class as much as possible. You are a good student, but you are not interacting that much, because, and suppose if you are having a doubt here or and anywhere, then you can directly ask me, sir, please tell me this thing is in this way, why this thing you have written in this way. So this is the better way to understand now you will getting or not, and I should improve otherwise if you are not getting. So okay, so this is the circuit, and this is connected with wire from here like this, and this is a battery here, this is a battery here, and suppose this resistance is R1, this resistance is R2, this resistance is R3, this resistance is R4, and one resistance from this point, by this is the wire, and we have connected one resistance like this, R5, and this combination of resistances is known as the Wheatstone bridge. Wheatstone bridge. Wheatstone bridge type of combination. But Hamza, you can see here in series combination there is current is same, means wire is same. So you can identify the series combination. And for the parallel combination, the voltage is the same. Then you can identify the circuit. But see here, you cannot identify which kind of, actually this is not any kind of combination. This is neither parallel or not series combination. So you cannot solve this combination easily. So for this, there is a method to solve it. If the ratio, okay, so just wait. So just wait, Hamza. I am just connecting it again. Hamza, now it's fine. My voice is okay now. And from the starting, my voice is breaking from the starting of the class, or just okay, fine. That is fine. Means okay. So Hamza, see here. Uh, okay, fine, fine. And thank you, Hamza. So Hamza, let's see. What is happening here? This type of circuit you will get if you are getting, and listen one thing, we will solve as much as as many as questions numericals I will solve, but I will give you the assignment. You will first try that, and we will discuss this assignment in the class. Okay, and your problem will be vanished inshallah in the coming days. You will see that. So here now let's focus here. If this ratio of this resistance and this resistance means if R1 divided by R2 is equal to R3 divided by R4, R3 divided by R4 is there, then you will say this is the condition of balancing condition. This is balancing condition. Balancing condition means there will be no current in R5. In this resistance there will be no current if this thing is valid. There will be no current in R5. In this 5 R5 resistance there will be no current, and I have already told you in the circuit we can remove the resistance having no current. In the short circuit I have told you type 4. So type third I have told you in the short circuit, if you have remembered that if no current is passing through the resistance, so it will behave like a single wire. So it will behave like a single wire. So we can remove the resistance from there. So I am just writing it again. If no current is passing, if no current is passing through the resistance, if no current is passing through the resistance, so it will not contribute to the circuit. Means so you can remove it. Okay, Hamza. So see here, as we know that there is no current in R5, I have told you this. If this is the condition following, then we can just remove the resistance R5 easily. And I will always try to tell each and everything with the reason. There is a reason for each and everything. So I discuss that as much as possible. So Hamza, see here, I have just removed this resistance. Why I have just removed this resistance? Because there was no current in this resistance and this condition is followed. We can only remove this resistance if this condition is followed. Okay. So we can remove this resistance. So Hamza, let's see. Now Hamza, you have to identify one more thing. this R1 and R2 are in series because there is no branching here. R1 and R2 are in series, and this R3 and R4 are also in series. Also in series. This R1, R2 and R3, R4 are in series. So we can find R12. R12 means equivalent resistance of this plus this. Means R1 plus R2 we can write if we want to find the equivalent resistance of this wire. Means we can write R34. So we will write R3 plus R4. And what we will do now, we will just remove the above resistances and we can write instead of this R1 and R2, we can just connect a single resistance of R12 ohm. Of R12. We can just connect this R12 here. And instead of that, we can connect here R23. Now, Hamza, can you tell me this R12 and this R23, which kind of combination is this? If this battery is connected like this, parallel or series? R12 and R23 are in series or parallel? Hamza, are you listening me? So please tell me. If you don't know, then you can write I don't know. If you know, then you can tell me. Okay, Hamza. So Hamza, I have told you earlier also, this resistance and this resistance are connected end to end. Connected end to end now. This R12. This R12 is connected from this end and this R23 is also connected from this end. Suppose this end is A, this end is B. So R12 and R23 are connected end to end. So you can write R12 and R23 are in parallel, are connected in parallel. And series combination is like this. If this R12 and R23 are connected like this is R12, this is R23, then you can say this combination is, can you identify this combination, Hamza? These two resistances are connected in series and parallel. Means I am asking this resistance and this resistance are connected in series or parallel. Hamza, actually this is the series combination. This is the series combination of resistances. Because in the beginning also I have told you, if the resistances are connected on a single wire, this is just the single wire, na? Is there any branching? Is there any branching, na? There is no branching on this wire. There is no branching on this wire. So this combination of resistance is series combination. Okay. Just wait. Just wait, Hamza. Hamza, hello. Now it's fine. I think there is some problem, and you can again tell me if my voice will break. Okay, you can again tell me because it will be fine for both of us. So Hamza, this is the series combination this time because there is no branching here. Means these resistances are connected on a single wire, but this resistance and this resistance are connected in parallel because see here from this point there are branches, so this resistance and this resistance are connected in parallel. And one more thing, from one more thing you can identify, see that this resistance is connected to this end and this resistance is connected also to this end. Same is the case with this point, this end. So you can say these R1 and R2 are connected in parallel. So for parallel combination, we can find the equivalent resistance. Equivalent resistance for parallel combination you can find 1 upon R12 plus 1 upon R23. So if you want to solve this, you will take the LCM, this multiplication of this and this, you will take the LCM. R12 you will take and R23 you will take this, and here you will write R23 plus R12. So R equivalent when you will find, you will reciprocate, means reciprocal of this, you will get, you will write R12 R23 divided by R23 plus R12. This is the answer you will get. And what is R12? Equivalent resistance of resistance 1 and resistance 2. And what is R23? R23 is the equivalent resistance of resistance 2 and resistance 3. Okay, Hamza? So this is the way to solve the Wheatstone bridge. So Hamza, now you can note it down, please. Or whatever you want to take the screenshot, then you can take. And we will solve one question on this also. Now the voice is okay, na? I don't want that you will get any kind of problem due to me. So I think you have taken the screenshot of this. Now I am just moving downwards. So now please take the screenshot of this, because notes are equally important. Okay, Hamza. Okay, Hamza, no need to write in the chat again and again. I will understand that you can take the screenshot in 3 seconds, or I will count till 5 seconds, then you can take the screenshot. So 1. Okay. Now you have taken the screenshot, and now I am moving forward, and now we will solve one question also. Now we will solve one question also. Now see the question. And Hamza, before solving the question, I want to tell you some more form of Wheatstone Bridge. So first, let's solve the question that you are saying that you are getting problem in solving the question. Suppose you are having the same Wheatstone Bridge, this bridge you have, same combination you have now. Please focus this time. Please concentrate here. I am just trying to solve your problem. Please focus here. This combination is given to you. And they are saying R1 is equal to 2 ohm. They are saying R2 is equal to 4 ohm. They are saying R3 is equal to 4 ohm, and R4 is equal to 8 ohm. So this R1, the value of this R1 we will write here. R1 is this 2 ohm. This R2 is 4 ohm. Means the resistances are connected like this. And this R3 is given as 4 ohm. And this R4 is given as 8 ohm. I am just telling how to solve the problem. And R5 is also given. R5 is given as 100 ohm. This R5 is 100 ohm. So you will write here this R5 is 100 ohm. And we have to find the equivalent resistance of the given circuit we have to find that. So Hamza, what we will do here, we have this circuit. We have this, and I have told you this is a combination of 5 resistances, and this is the Wheatstone bridge, and this is Wheatstone bridge. This is Wheatstone bridge circuit. So what you will check? First you will check the R1 by R2 should be equal to R1 by R2. Is there R1 by R2 is equal to R3 by R4? We will check. Value of R1 is 2 ohm and R2 is 4 ohm and R3 is 4 ohm again, and R4 is 8 ohm. Now divide this will become 1 by 2. This will become also 1 by 2. So you can say this thing is equal, means R1 is equal to R1 divided by R2 is equal to R2 divided by R4. So both are equal. So if this condition is valid, so you can say there is no current in R5. You can say no current in R5 or 100 ohm resistance. 100 ohm resistance. So if there is no current, so you can just remove this resistance from here. Now I am telling how to solve the question. You can just remove the resistance from here. Okay, Hamza? So is my voice is okay now? Okay, fine, Hamza. Uh, Maybe tomorrow I will change my mic also. So this condition is valid in this circuit. So we can say now we have to solve this, and we know I have already told you this 2 ohm and 4 ohm is R1 and R2 are connected in series, and R3 and R4. Now you have to solve this circuit. You can say R1 and R2 are connected in series combination. See, this is R1 and R2 are connected in on same wire, means series combination, and R3 and R4 also. You can find R12. So you will write R1 plus R2. So R1 is 2 and R2 is 4. This will become 6 ohm. So similarly, you can find R34, R34, R3 plus R4, and R3 and R4 also connected in series combination. So you can write 4 plus 8. So you will get 12 ohm. Now this R12 and R34 are connected in parallel, means you will write 6 ohm and 12 ohm are connected in parallel combination. Okay, so you can find the equivalent resistance 1 upon 6 plus 1 upon 12. So take the LCM of this 12. This will become 2. This will become 3. No, not 3. This will become 1. So this will become 3 divided by 12. So you will get 1 by 4. And this is 1 by R equivalent. When you will calculate the R equivalent, you will get 4 ohm. Means 4 ohm will be the answer of this question, because the earlier this was the question. Now how simple this question is, if you will apply the concept of this, you will just remove this resistance, and thus for solving this combination. Okay, Hamza. So in this way you should solve the question step by step. You should solve the question step by step. Okay, Hamza, take the screenshot of this. Okay, I think you have taken the screenshot. Now take the screenshot of this. Okay. Done. Very good, Hamza. So in this way, you will solve the question. Means you have to remember the steps that I have told you, and this will happen when you will revise your notes, when you will solve the assignment. Then only you can easily solve any type of question. So now we will discuss some different form of Wheatstone Bridge. Different form of different forms of Wheatstone Bridge. Different form of Wheatstone Bridge. And these combinations of Wheatstone Bridge I am taking from the previous year questions that were already asked in your examination. Examiner will confuse you. Examiner will confuse you. See how the examiner will confuse you. You have this combination now. This combination you have. This combination is called as the Wheatstone Bridge combination. So suppose this combination is like this, but the examiner may give you this combination like this, may give you this combination like this. He will connect a resistance here, here, here and here, and also a resistance here, R1, R2, R3, R4 and R5, and this is connected with battery like this. The battery connection is very, very important, from where we are connecting the battery. So this combination is also the Wheatstone bridge. Okay, this kind of combination is also Wheatstone bridge. What we have done here, see Hamza, here one thing, that this is the wire na, this is the wiring, and we know then resistances are connected on the wires. So if we are folding this, suppose that three resistances are connected on this wire. So suppose I am just folding this wire like this. If I am folding the wire, the combination will remain same. Means the position of the resistance will remain same with respect to the wire. It will remain same. Means when you are doing like this, the current will same throughout the wire, and the resistance will remain on the same wire. The combination will remain same. In the same is the case here. Here the wiring, here just the wiring change, means this wire is changed to this form and this wiring is changed to this form. So this is something different, but these both circuits are same. Both circuits are same. This is also the Wheatstone bridge. This is also Wheatstone bridge. Okay, and this is the battery here. And this Wheatstone bridge can also be represented in this form also. There is one more form also. This is a square form, this is circular form now. Please focus here. So what will happen? I am just connecting a resistance here like this, and I am connecting this circular wire with some battery here, and I am just connecting a resistance here. I am just connecting a resistance here, here, and I am just connecting a resistance here. This is R1, this is R2, this is R3, and this is R4, and this is R5. So Hamza, this is also Wheatstone bridge, but the shape or the geometry of the circuit is changed. But see here, R1, R2, R3, R4. In between R1, R2, R3, R4, there is a resistance R5 is connected. This is also known as the Wheatstone bridge. So there is one more form of Wheatstone bridge. There is one more form of Wheatstone bridge. This is looking like this. Suppose two resistances are connected here and two are connected here and one is here. So if this type of combination is there na, this type of combination, and suppose the battery is connected from here, battery is connected from here, from this point. This is R1, this is R2, this is R3, this is R4, this is R5. So this combination of resistances is also the Wheatstone bridge, but here the structure of wiring is changed. So you have to remember that. And there is one more famous form. there is one more famous form that you will see in your examination, and there is one more form of Wheatstone bridge, that suppose three resistances are connected like this on a wire. Three resistances are connected like this, and I have just connected one resistance like this, and I have just connected one resistance like this, and this is a point A and this is a point B. This form of resistance is also known as, this is R3, this is R4. This combination of resistances is also known as, this is R5. This is also the one of the form of Wheatstone bridge. So this is one. So these are the forms of Wheatstone bridge. So Hamza, now please note it down and please tell me if you want to ask any question. If you are having any question, you can ask me. Okay, Hamza. So you should know this form, but also this form, this form, this form, and this form. You should also know that these all are also the form of Wheatstone bridge. The question can be given in this form also to you. Okay, Hamza. Question can be given in this form also. So please take the screenshot of this, or if you want to note it down, then you can note this. And Hamza, if you have any doubt that why this combination is Wheatstone bridge, this combination, so you can now ask me also. I have just explained you already, but I will explain you again also, because I know that you may get some problem here, that how this can be the Wheatstone bridge, this wiring, these both circuits and are not same. So how this can be? But we also know that the resistances are connected on the wires, so we can just manipulate the wiring. Okay, so accordingly we can get the similar combinations. So I think you have took the screenshot of this. So now take the screenshot of this also. So in case of circuit analysis, one circuit can be drawn in many forms. You will get the same equivalent resistance. So Hamza, taken the screenshots. Hamza, you have took the screenshot of this. Okay, means you have also already this also you have completed. Okay, Hamza, I think you have completed now. So there is one more thing here, but the examiner can confuse you. The examiner can confuse you by giving this kind of combination. But you should not confuse, because you know this is the form of this combination, and this is Wheatstone bridge, this is also Wheatstone bridge, but this is just the different form of Wheatstone bridge. So now I will tell you about the circuits which will look like the Wheatstone bridge, but in actual they will not be the Wheatstone bridge. circuits which are not Wheatstone Bridge. Okay, circuits which are not Wheatstone Bridge and looking like Wheatstone Bridge. So just see here. Please focus here and see here. I am just drawing it. So suppose one resistance is connected here, one here, one here, one here, and this is R1, this is R2, this is R3, this is R4, and one resistance like the Wheatstone Bridge we have connected R5 here. And one thing here is, but the battery is connected like this. Here the battery is connected like this. So this is looking like Wheatstone Bridge, but this is not the Wheatstone Bridge, because you can see that this R1 and R3 are in series, and this R2 or R4 are in series also, and equivalent of this, and this R5 are in parallel. So you can solve this circuit. This is not a Wheatstone Bridge. And there is one more thing, means one more circuit that is looking like the Wheatstone Bridge but not the Wheatstone Bridge. Suppose the resistances are connected like this, and I have connected the battery here. I have connected the battery like this. So again, this is not the Wheatstone Bridge, because this is a finite combination, means this R1 and R3 are in series, and with this R1 R3 this R5 in parallel, and with this whole equivalent this R2 is in series, and with this whole equivalent this R4 is in parallel. So the story is this, the theme of the story is this is not the Wheatstone Bridge, because here are some finite conditions. Here we can identify this R1 and R3 are in series, but here we cannot identify na R1 and R3 or R2, R4, R5 are in series or parallel combination. So these are the forms of Wheatstone Bridge. An examiner will confuse you by giving this type of questions, but you should not confuse, because you know that in a Wheatstone Bridge we cannot identify any of the resistors, whether they are connecting in parallel or series. But here we are just identifying, here this R1 and R3 are in series combination, and R2 and R4 are in series combination. Okay, so now you can take the screenshot of this also. So you have to remember this, all these things you have to remember. Hamza, have you got my point? What I have told you, what I want to say? Okay, very good. Why this is not Wheatstone Bridge? Because we know that this is a finite combination, means here we can just identify this two resistances are connected in series, but in Wheatstone Bridge we cannot identify until and unless the ratio of the resistances are equal. So this type of questions you can also get. Okay, Hamza. So I will start a topic, infinite series problem topic. Okay, so that topic may be complex, little bit complex for you, so that I want you should take at least 5 minutes of rest. Okay, and after that I will start, because we are studying continuously from 1 hour. So I will start that topic, infinite series problem. So that topic is maybe little bit complex for you. I want that you should relax for 5 minutes and we will meet after 5 minutes. Okay, and please don't leave the meeting. Okay, Hamza, is it fine now? I'm just giving you some relaxed time so that we will start that topic because that topic is can be complex for you. Okay, Hamza. So just we will meet after 5 minutes. Don't leave the meeting. Hello Hamza, are you there now? Okay Hamza, now okay fine. Now we will solve a very beautiful circuit. Okay, now let's start. So now we will solve the infinite series problem. Infinite series problem is a type fifth we have. Type fifth we have. Type 1. Type 1, what we have type 1? In type 1 we have mm, that mixed combination means we have connected the cell and identify the resistances. In type second, we have the potential divider method. In type third, we have, this is type 4 actually. So in type third, we have short circuit, and type fourth, we have the infinite series problems. Infinite series problems. So please concentrate this time very carefully. This is something different type of combination. So this, suppose if the combination is like this. This is the battery and the resistances are connected like this. Resistances are connected like this. Means here a resistance and here another resistance is connected. Here one resistance is connected. Here another resistance is connected. Here one resistance is connected. Here another resistance is connected. Here one resistance is connected. Here another resistance is connected. Here one resistance is connected. Here another resistance is connected. So this combination goes till infinite. This combination goes till infinite. Means there are large number of resistances that are connected. There are large number of resistances that are connected like this. That are connected like this. And now concentrate here. This is the battery connected and all the resistances have same value, that is R I am supposing. And this combination is, means these all resistances are connected infinitely, means this circuit is infinitely long, means a large number of resistances are connected like this, and you have to find the equivalent resistance of this. So Hamza, what you will do, you will just follow the steps for solving this circuit that I am telling. So for solving this type of circuit, you will just follow the steps that I am telling to you. Step 1. In step 1, what you will do, you will find out the repetition term in this circuit. You will find out the repetition term. Repetition term means the combination, means the resistances which are repeating. This is repeating again and again. These resistances are repeating again and again now. So we have find out the repeated term. This thing is the repeat. This thing is repeating again and again. This and this thing in the circuit. This thing is repeating again and again. This is the repeating term. This is the repetition term in this circuit. In the step second, what you will do? In the step second, you will do as you have given this infinitely long circuit and resistances are connected in repeated form. What you will do? You will assume R equivalent as the equivalent resistance of the given circuit. Means you will assume that this circuit have the resistance as R equivalent. And now what you will do in step second means this whole circuit have the resistance R equivalent. Okay. Now in step third, in step third, what you will do? You will just add one more repetition term. Adding one more repetition term in the circuit. So what you will do? You will just add one more repetition term like this. This is the battery. Repetition term like this, and you will connect it with the equivalent resistance. This is the repetition term now. You have seen this is the repetition term. You have connected this repetition term with this R equivalent. So Hamza, this resistance and this resistance are connected in parallel. So I am supposing this as one resistance, this as two, this as this is R equivalent. Okay. So you will write 2 and R equivalent. 2 means R2. This is R2 and R2 is equal to R here. R2 and R equivalent are connected in parallel. See, this is the end-to-end connection. So you can calculate the equivalent of this and this. So you will write the equivalent of this and this. You will write R into R equivalent divided by R plus R equivalent. And along with this resistance R is connected in series, and this whole resistance is equal to the equivalent resistance. This whole resistance means just I am removing this step. Okay, fine. So now see that what will happen if you will add one resistance in this one repetition in equivalent resistance. Means you can write adding one repetition term will not effect the equivalent resistance R equivalent. And if suppose these are the resistances, and there are infinite uh, repetition terms connected, means this is the infinitely long resist circuit. And what will happen if you have one infinite, and infinite is very large. If you will add one in the infinite, it will remain infinite. So same is the case here. This R equivalent is very large. If you are just adding this one repetition term, this R equivalent means the resistance of this whole circuit will remain R equivalent. Okay, Hamza. So you can write, these are in parallel. So you can write R equivalent means the equivalent circuit, means equivalent resistance of this circuit is equal to, now calculate the equivalent resistance of this circuit, means this will become R into R equivalent divided by R plus R equivalent plus R you will write here, because with the equivalent of this is connected in series. Now we can solve this. We will take the LCM. So take the LCM here, R plus R equivalent, and now cross multiplication you will get R into R equivalent plus, when you will multiply this you will get R square plus R into R equivalent. This is the calculation that you can do it easily. So now you will multiply this with this will become R into R equivalent. This will become R equivalent square equal to, this is R into R equivalent, this is R square, this is R into R equivalent. Now Hamza, this R into R equivalent will be cancel out. So you can write R equivalent square minus R into R equivalent minus R square equal to 0. Now we have this equation. See, Hamza, now we have this equation. And do you know something about this equation? Which this equation is known as the quadratic equation. Quadratic equation in 10th class we have studied ax square plus bx plus c equal to 0. So Hamza, tell me one thing, do you have biology in your 12th class or mathematics? You are a student of maths or bio? Oh, means you are a math student, na? You are having math in 12th or something else? Okay, fine. Means you are a math student, then I can assure that you should know this thing, quadratic equation. This is quadratic equation. Quadratic equation. Okay. This is the quadratic equation. And now you will compare this equation 1 with this equation 2. Actually, Hamza, here we have solved the question already. But here what we are doing now, we are dealing with mathematics. This is mathematics. So when you will compare this equation with this, so x square is equivalent to R equivalent square here. So if you will compare, then you will get the value of A as 1, because the coefficient of r square. A is the coefficient of x square. So here the coefficient of r square is 1. So you will take A as 1. You will take the coefficient of r equivalent, that is x, and x is r equivalent. So you will take this minus r as b, and c, for c you will take this minus r square. And why we are writing this? Because we are comparing equation 1 and 2. So now if you have a formula for calculating the x, minus b plus minus under root b square minus 4ac divided by 2a. So if you want to write in terms of r equivalent, if you want to find, then you will write again, then you will write minus b plus minus, because x is equivalent to r equivalent, x is equal to r equivalent, plus minus b square minus 4ac divided by 2a. This is math, purely maths. Now what is b? You will write b as minus r, plus minus b square means minus r square, minus r square. We will solve this here. So Hamza, we will solve it here. So r equivalent we can find, minus b we have minus 1, minus b we have 1, means what is minus b? Oh, minus b is minus r. So minus b is minus r, plus minus b is minus r square, b square means minus r square, minus 4, a is 1, c is minus r square, and this is 2, a is 1. A is 1. So r equivalent, when you will calculate, you will get this minus minus plus r plus minus. This is just the simple calculation. The square of this become r square. This will become plus 4r square, and this will become 2. And from here you can calculate the r equivalent as r plus minus. This will become 5r square divided by 2. You can get from here 5 root 5r you can get from here, and this is 2. So you have r equivalent as r plus, first you will take plus sign, r plus root 5r divided by 2, then you will take r equivalent equal to r minus root 5r divided by 2. Then take here r as common, so you will take r common, then it will become r by 2, it will become minus 5. So this is term is less than 0, but r equivalent can never be 0, means resistance can never be 0. Resistance can never be less than 0. Resistance can be 0, but cannot less than 0. How the resistance can be 0? So you can write r equivalent as this, you will reject like we do in the quadratic form. So the answer is, you will take common, you will get 1 plus root 5. So this is the final answer of this type of combination. So this is the circuit, we have successfully solved it, and you have to follow the steps as I have told you. Now Hamza, please take the screenshot of this. After this we will have just one question and I will leave the class. Just one question on the same topic. So Hamza, have you taken the screenshot? So you can just imagine that we have connected the one more resistance. Okay. Now take the screenshot of this. means from here. I think you have completed this screenshot part. Now take the screenshot of this, and I am telling you this is very important circuit. So Hamza, please tell me, have you completed? Now we will just solve one question, and after that I will leave the class, and we will meet in the next class, inshallah. Taken the screenshots? Should I scroll up? Hamza, have you completed this? Completed? Beta completed, Hamza? Hamza, where were you? I'm just asking you. Should I complete the question in the next class? Okay, okay, fine, that is fine. So should I give you the question now? Just one question. Okay, fine. Just I will also take water. Just wait. Okay, Hamza. So the question is, and the question is based on this combination. Means you have the question like this. And from here, from this resistance, our battery is connected. And all resistances are of 1 ohm. All resistances are of 1 ohm, and this these resistances means this combination is very large, means infinite combination. There are large number of resistances connected like this. So first step to solve this, to identify the repetition term. So repetition term is this. This is the repetition term everywhere, you can see. This is the repetition term. So what you will do, you will consider the equivalent resistance of this resistance as R equivalent. R equivalent is the equivalent resistance. So you will connect this R equivalent with this combination. R equivalent with this combination means R equivalent is this, and you will connect this like this. Means this is R equivalent. Now you will connect the repeating term with this. Okay, fine. Fine. So this is R, this is 1 ohm, this is 1 ohm. So this is 1 ohm, this is again 1 ohm, this is again 1 ohm. So what I have done, I have just considered R equivalent is the resistance, equivalent resistance of circuit. I have written the steps, you can check there. And after second step is connect R equivalent with one more repeating term, and the equivalent resistance of this circuit is also R equivalent. So now calculate the equivalent resistance of this circuit and equate it with this. So equivalent resistance of this circuit, this R equivalent and this is in parallel combination. So you will write this multiplication of this and R equivalent plus 1 you will write, and plus 1 and plus 1. Why we were writing? Because with the equivalent of this and this are connected in parallel, series, sorry. So you can just solve this. So this is R equivalent divided by R equivalent plus 1. This is 2. This is R equivalent. Now you can solve this. Take the LCM of this. So you will get the LCM of this R equivalent plus 1. Okay. And you will multiply this R equivalent. This when you will multiply this will become 2 times of R equivalent plus 2, and this will become equal to R equivalent. Now this R equivalent plus 2 times of R equivalent plus 2, this will, when you will multiply this will become R equivalent square plus R equivalent. Fine. So this R equivalent and R equivalent is cancel out. So you will make the quadratic equation R equivalent square minus 2 times of R equivalent minus 2 equal to 0. So here when you will compare from ax square plus bx plus c equal to 0, so you will get a equal to 1, b equal to minus 2, c is equal to minus 2 you will get. So similarly you can find R equivalent as minus b plus minus b square minus 4ac divided by 2a. So R equivalent is equal to minus b means minus 2 plus minus b square means minus 2 square minus 4a1. What is c? C is minus 2 again. So divided by 2a is 1. So here you can write R equivalent minus minus plus 2 plus minus you will get this 4 plus 4 to the 8 you will get, and here you will write 2. So you can write this as 12 divided by 2. You can write this 2 root 3 you can write this, and divided by 2 you can write it. So R equivalent, what you will take? You will take the positive sign. You will take the positive sign. So you will write 2 plus 2 root 3 divided by 2. Now you can take 2 common. From here you will get 1 plus root 3 divided by 2. Now 2 and 2 cancel. R equivalent you will get the answer 1 plus root 3. Okay. Root 3 you will get the answer. Now in this way you have to solve the question. You can check the step I have written earlier also. So now you can note it down. Just take the screenshot of this question. Taken the screenshot now? Hamza? Taken? Taken the screenshot of this? Very good. So now this, take the screenshot of this. Means you have taken this now. Take the screenshot of this now. Take this. Taken na? Okay. I think you have taken. Okay, now just last part. Take the screenshot of this also. And I am leaving class here. And I expect that I will give you the assignment, and I am expecting that in the next class at least you will solve that. Okay, Hamza. Thank you. You can leave now.